Okay, so again, good day everyone. Our topic for today is about catalog of model transformation. So actually, I just want us to finish as early as possible because I just want you to focus actually in your software development. I think we just only limited time na no for you to accomplish all your activities and assignments with my subject. So looking forward that we'll be able to finish our topic as early as possible. No? Okay, so as I mentioned earlier, no, our topic for today is about catalog of model transformation, no, and the model transformation is a UML that can, of course, describe, no, no. Again, the model transformation is the UML that can be classified in 5 categories. Now we have the refinements, we had quality improvement transformation, elaboration, abstraction, and so on. Okay, so and of course, yung design patterns, no. So these transformation are used to refine a model towards an implementation, and there are certain, of course, transformation of the replaces of some inheritance relationship between two classes by an association between the classes, and so on and so forth. So to give us more details about the topic, let us all welcome our presenter. Go ahead, madam.
Thank you po, Doc. Wait, ayan. Sorry. Wait lang. Okay po. So, okay na po, sir. Kita na po yung screen slide ko. Okay, sige, thank you po. So, good morning, everyone. Good morning, classmates. In this chapter 11, Catalog of Model Transformation, I'm going to summarize all the transformations that we have been used in the previous subjects, together with the other well-known model transformations. So, let's start. So, as with the design patterns, which can be considered as a special kind of model transformation, there are many variants of model transformation that are possible. And some of this will also be described. So Doc Marmelo have mentioned actually all of them na earlier. So the 5 main categories of these model transformations are: first, the quality improvement transformation; second is elaboration; next is refinement; next, abstractions; and lastly, the design patterns. So we will go through it one by one, and each category has a subtopic then, and I'm going to discuss that. Okay, so let's start with the quality improvement transformation, the first category or model transformation. So in this transformation, the aim of this transformation is to provide, let me just minimize, is to provide, improve structure of a model, making it conform more closely to a normal uses of UML notation, or improving its precision or its flexibility for extension and adaptation. We have 2 general categories under this model transformation, and these are the removal of redundancy, this one, removal of redundancy, and then the factoring out or decomposition of elements. And yeah, let's proceed with the removal of redundancy, this one. So the removal of when we say removal of redundancy, it gave us or introduced us a superclass transformation. So this example is from the word itself, removal of redundancy, removing of redundancies of any data redundancy in a specific model. And normally redundancies should be eliminated, of course, right? So yun naman yung tama, because we don't want duplication in our data or sa system, di ba? And yeah, redundancies, that's duplication because they complicate a model unnecessarily, and if implemented, it will lead to extra work and possibilities for program flaws. So yun, extra work and program flaws. Other example of such transformations are the removal of redundant inheritances and association. So when we say inheritances, inheritant na mamana. So sa program there is what we call inheritance, na there's parent and child inheritance. I'm not sure if you're familiar with that one, but of course, if we're gonna relate that to real life example, so yung child, merong mga na-inherit from the parent, yung mga namamana like matangos na ilong, maitim na balat or maputing balat, same then with the system, no? Applicable din siya. So, next, eto na siya. The first part of removal of redundancy is remove redundant association. So this one, it is an explicit association which can be computed as a derived association from other model elements, is made implicit and derived or eliminated completely. I have here the figure as example here on the right side. So such associations duplicate information needlessly. So even though we don't need it, naduduplicate niya, and that's the thing that we want to avoid. And in an implementation, the overhead of maintaining consistency between the association and the information it duplicates could be considerable and prone to errors. Of course, we are avoiding redundancy or duplication because it is prone to errors. So medyo blurry lang yung example ko here, but if you are going to look with the example, look at table A and table B. I have here integer and then real, while sa B, integer, boolean, and boolean. So anong the same, they have the same integer and integer here. Now, pag na-transform na siya, as you can see, real na lang yung naiwan and then the boolean here. So where did the integer go? So meron ditong new table A or B, and here na yung integer because they are both the same naman. Pinag-isa na niya. They remove the redundancy na. And then under it, integer. So this one is a different kasi. Kaya andun pa rin siya. And then we have integer, integer, real, andun pa rin siya. So yun lang. To simplify this one, the duplication or the redundant data here is the integer and integer. And pinag-merge niya dito and nawala siya rito. So that's the example for that one. Let's go to the next one. Eliminate redundant inheritance. So for this one, if a class inherits another by two or more different paths of inheritance, remove all but one path as possible. So redundant inheritance, it conveys no extra information, but simply serves to complicate the model. No, yeah, it makes our model complicated. So the figure on the right side shows a typical situations where class A directly inherits from class C, and also indirectly via a more specific class B. The first inheritance is redundant and can be removed. Redundant, diba? A is pointing to C and then pointing to B, while as you can see, B is pointing to C din naman. So the arrow tells us na yung A, makakadaan din siya sa B and C both. So no need na rito. That's why here's a transformation na nawala itong arrow na to, because as we all know, A will pass through B and then from B will pass through C. So lahat madadaanan niya. So yeah, that's the figure. Next, so to add, the first inheritance is redundant and can be removed. So in some other language, for example, Java, this inheritances would actually be invalid, automatically invalid siya. Next is remove redundant classes. So classes may be redundant because they are essentially duplicates or of other classes in the model but with a different name or because they are not needed in the system being defined. So duplication of classes will lead to overcomplex model, which are difficulty to modify and analyze. So if you're gonna look at the first picture on top, parang complicated siya tignan. While pag after niya ma-transform, ito na siya. So simple na lang. No? Nabawasan siya ng table here kasi pinag-merge na niya dito. So yeah, the figure shows a typical case where class A and class B are almost identical and can be replaced by a single class. As you can see here, integer, integer, real, real, pwede naman siyang pagsamahin. And then X CR size, Y CR size, eto na siya. And then here. Next is merge partial classes. So this one, classes may define only a part of coherent concept. Other parts may be expressed in different classes and their commonalities have not been recognized. So this transformation merges such classes into a single class. So for this one, wait. If you are look at the top image now, we have the user table and the person table. The name are string, both are string, user ID string, however wala siyang kaparehas dito, password string din, pero wala siyang kaparehas here, address string, age string. The only thing that they are the same or duplicated here is the name string and then name string. Ayan. And as we all know, user, that's a person din naman, right? So they are the same. So if we're gonna merge them from the word, from the title, from the name of the transformation model, merge. So merge is we are combining them. Pagsasamahin natin yung mga redundant. Okay? Unlike yung mga first model transformation I just explained, we are removing them. No? So when you remove them, tatagalin natin siya sa data. But here we are going to merge them to become one. Parang ganun. Okay? So we have here name string. Isa na lang kasi yun lang naman yung same nila. User ID, password, address, and age. Nandito pa rin naman sila. Okay. Ayun po. Next is factoring, the second model transformation, factoring. So this is another group of transformations. Improve a model by factoring out certain groups of features from a class into new classes or interfaces, or factoring common features of a set of states into a new superstate. So for us to understand this one better, I'm going to proceed with the subtopic. First is introduce interfaces for supplier classes. So if class A is a client of class B, but only uses some of B's features, introduce an interface of BI of B, which has the subset of operations of B that are used by A. Make A client of BI instead of B. Yeah, BI. Yeah, okay. So for this one, this reduces the dependencies in the model and enables separate development of A and B. And it also permits them to be placed in different layers or tiers of the system. The figure here on the right side shows that A must only depend on the specification of operations of B, not on their implementation. And also, it is an example where it is important to factor out different interfaces of a class for different clients. Example is password database, where general users can only use the check and set passwords operation, while the system administration can delete and create user records. So these two persons or users have uh, different things na they can do sa password database. Okay. Let me just, okay. Next is disaggregation. So for this one, the class is factored into a component classes. So a class may become large and unmanageable. So with several loosely connected functionalities, it should be split from the word itself, this aggregation. We're splitting it or breaking it down, parang ganon, into several classes, such as a master or controller class and helper classes, which have more coherent functionalities and data. So the helper or the component objects always exist when the master object delegates operations to them. For example, the best example I can give here is the transformation to separate the helper classes of the edit user page and login page. So yeah, and yeah, from the servers of the property system. Another case where it arises is in breaking up large web forms into several smaller forms. Like here, in the picture and the figure, it shows an example. For this one is actually a student accommodation agency. So we have here on the top left the large table na we disaggregate or we split it into small tables. Ito po. Next is factor out sub operations. So an operation is factored into sub operations. An operation may involve complex or repeated sub-computations. This can be factored into a private helper operations of the same class invoked from the operation. Now, the figure shows a generic example where a complex expression is factored out into a separate operation, the MI. It should be checked that the helper operations do not already exist in the class or in other classes before they are created. And this transformation uh, will combine with introduce classes. It gives a template method pattern. In the case that methods in two separate classes have the same remainder after their helper method code is factored out. So for this one, factored out, parang the same din siya sa disaggregation na splitting out from complex and manageable data. They broke it down to pieces then like this. Ayan, 'di ba? Here. Next is introduce derived features. So this one, it is an expression E built from local features of a class, which recurs several times in a specification. It is replaced by a new derived feature, f of the class plus the constraint f minus e. So this one, complex repeated expressions lead into inefficient implementations. So a derived feature, this represent the expression need only be to be recomputed when one of its feature defining feature changes the value. An example for this one is a Scrabble system. Scrabble system where is the introduction of rack size in place of the rack letters size. Ganun. Breaking down, so booking ID, so accommodation, booking. So this one is so broad, di ba? So when we say accommodation, sino, who, where, what, parang ganun, di ba? So booking ID, so under it we have personal details, so nung nag-book, and the course details. Yeah, about the course nung person na yan, and then preferences, so we can say that maybe smoking or self-catering hall, yan. So by the way, Boolean, string, integer, and Boolean, if you're not familiar, these are data types po, no? So string, letters, integer, these are numbers, boolean, these are answerable or answerable by yes or no, as Sir Pantaleon mentioned earlier, yes or no or true or false. Okay, so two lang yung pupuntahan niya, either true or either false. Like for example here, so do you prefer a smoking room ba? Yes or no, true or false. 1, 0 pag binary. Ganun. So year, integer. It's because we know year, numbers yan. Ayun po. Next is introduce superstate. This reduces the complexity of the diagram. The number of transitions is reduced by n minus 1, 9m, and may identify a conceptually significant state that was omitted from the original model. So basically, from complex to simple, from complex figure or from complex diagram to simple diagram. Yun lang naman yung nare-represent niya. So the new state can only be introduced if it does not overlap with the other states, except those who entirely contains or is contained by. So yeah. So ayun, again, from complex to simple diagram. Next is introduce entry or exit actions of a state. So this transformation, this reduces the complexity and redundancy of the diagram. It may correspond to a more efficient implementation. Of course, I agree more, no? More pagka hindi complex yung hindi complex yung diagram or yung no redundancy, no duplication, mas efficient yung application. Kumbaga, less is more. Diba? So if all transformation into a states have the same final sequence act of actions, so factor this out and define the entry action of S to be act instead. Likewise, if all transitions which sources have a common initial action act, this can become the exit action of S. So next, the third one is other quality enhancement transformations. So another group of transformations improve a model by a quality enhancement, transforming a set of states into a new superstates. So under this one, we have raise supplier abstraction level. So actually, from redundancy kanina, no, na medyo simple yung example, nagiging complicated na me myself. I'm having a hard time understanding the diagram, so please pardon me. So for this one, if A depends on an over-specific class, this reduces the independence of parts of the system and makes it less easy to modify. If we are going to look at the table, if class A is client of B and a subclass of C, make a client of A of C instead if A only uses features of property C. So as you can see here, again, class A is subclient of class B. I mean, client of class B, while class B is subclient of C. So why not make client A directly use the feature of C? That's why, ayan o. From yung na-notice nyo yung changes ng arrow from A to B, it became A to C na. So that is raise supplier abstraction level, as easy as that. Next is express OCL constraints graphically. So this makes the properties of the model more immediately visually apparent, more readable and comprehensively by a wider range of people and analysis tools, and more concise. So I don't have an example or diagram or figure for this one, but this replaces textual constraints by equivalent diagram elements. So examples are multiplicity constraints on association ends, cardinality constraints on classes, subset constraints between associations, and also if a particular kind of constraint is needed frequently in a domain or system, then a new UML stereotype abbreviating the constraint can be introduced by means of a profile and used in the diagram instead of the constraint formula. Um, Also, the identity stereotype of attributes, it's actually an example of this approach, no? UML, it allows new graphical icons or display styles to be used to indicate stereotyping. In addition to that is identifying of attributes could be written in bold font instead of labeling them with identity. So more on graphic, no, more on sa GUI siya graphically, visual. Next is make partial roles total. So for this one, total associations are generally easier to implement and manage than partial associations. I agree then with this one. So one multiplicity role of a class A may be turned into a one multiplicity role of either moving the role to a superclass of its current target or by moving the other end to a subclass of A on which the association is total. The figure on the right side shows the generalized target version of the transformation. Yeah. So this is B, B or C. Nag-combine din. A, B, or C. But for this one, the main idea is it's saying that it's easier to implement and manage the general rather than yung partial. Okay. Next is introduce module. So this one groups together related classes into a single unit. Example given, a UML package or subsystem. Improves modularity of a model. So for this one, the classes must represent a coherent unit. Normally, if a class is included in a module, so are its subclasses, aggregate part classes, and those classes which are suppliers to it and not suppliers to any other classes. Okay, so here, it's the same here naman. But on the left side, as you can see, we have the table here, more information. Introduce module. So these are the module of these tables. And yeah, grouped together, they are grouped together here. Next is simplify postconditions. A number of logical transformation can be made on postconditions of an operation to simplify its specification. It is important to make postcondition as clear and simple as possible to improve analyzability and readability. Analyzability, is that even a word? Sorry. Me myself got confused with this one. But oops, where? But for example, two post conditioned with the forms of A minus B and A equals to C can be combined into a single post condition like A minus B and C. So combining of two formulas or two post conditions. So two post conditions with forms A is equals to N minus C, then B is equals to N minus to C can be combined into A or B. So simplifying. So if you, again, yeah, I mentioned if we have two formula or post condition, if you're gonna combine them, we are actually simplifying them. Next is elaborations. So I think this is the fourth category na under the model transformation. So these transformations enrich a model with additional information. It includes obvious transformation like adding attributes, operations to a class, adding new classes, adding new subclasses, adding constraint to a class, operation state, association, and etc. This also includes creating of constraints more precisely, such as restricting a multiplicity range of a role and or restricting the type of an attribute. So if you have a restriction, if you're going to apply restriction to your system or whatever you're making is, you are actually making it more precise accurate. Ganyan. These changes may introduce inconsistency into a model, so care is needed in their application. Okay. So I only have one subtopic for this one, which is the reduced role multiplicity range. So this one, reducing multiplicities reduces the data storage requirements of the system and may enable the use of simpler data structures. Example given are arrays instead of lists. So so more on sa programming related rin to, like Python, and so Python lang ako familiar, arrays and list. It also improves the possibility of verification via tools such as model checkers. So let's look at the table. A or B, multiplicity role of a class A to class B may be reduced to a 0p or a minimum of B. That's why from BR here it became 0p na. If we know the domain or other knowledge that P is the maximum possible number of P objects that the association can link to one object, and in particularly if B has cardinality P. Yeah. Next is refinements. So refinements, this transformation are used to transform a PIM to a PSM, or to make the PIM more easy to transform to a PSM. For removal of many to many associations. Explicit many-to-many associations cannot be implemented using foreign keys in a relational database. An intermediary table will need to be used instead. This transformation is the object-oriented equivalent of introducing such a table. So I know most of you naman is familiar to many association or relationship and the foreign keys, because we have been discussing this under Sir Al, Dean Al. This transformation replaces a many-to-many associations with a new class and two many-to-one associations. A new class must link exactly those objects that were connected by the original association and must not duplicate such link. So here, from one-to-one, it became many-to-many na. Removing of many. Sorry, I'm confused, but yeah. Many-to-many. So we have here new class na rin, AR and BR. Okay. Next is removal of association classes. So for this one, this transformation replaces an association class with a new class and two associations. Association classes cannot be represented directly in many object-oriented programming languages. So the new class must link exactly those objects that were connected by the original association and must not duplicate such link. So if we are going to study the figure, as we can see, A is connected directly to B, and they have association class here. But again, this is a removal of association classes. They remove it and instead they connected to it directly na. Next is weakening preconditions or strengthening postconditions. So an operation precondition can be weakened so that it is possible to be applied in more situations without error, and or postcondition strengthened so that its effect is determined more precisely, and both potentially move the method closer to implementation. So if we are going to look and study the figure, it will say it should we need to take note in our mind that the precondition of the operation is in any interface used by a client will be the only precondition that such client can assume. Working to a more general and weaker precondition in a subclass is an issue of defensive programming. improving the robustness of the actual simple implementation of the operation so that even if the client does call it in an apparently invalid state, the operation will still have defined behavior. Next is replace inheritance by association. So this transformation replaces inheritance of one class on another by an association from the subclass to the superclass. This is useful to remove situations of multiple inheritance from PIMS. Example given is the transformation of the Java-specific PSM or for construction of a relational database schema. So here, B is pointing to A. I mean, yeah, So A, I mean, B inherited the inherited class, I mean, yeah, B inherited classes from A, and instead of inheriting it, we replace it by association. So B and A, they are linked to each other na. They are associated na. Replace association by attribute. So in UML 2.0, attributes of a class are equivalent to certain forms of association from the class. Embedding an association into a class as an attribute can be used as a step towards implementing it as an attribute of the class. So actually, qualified associations cannot be represented as attributes because there is no corresponding attribute notation. For example, specifying map data structures. In addition to it, the multiplicity of at the owning entity end of an association cannot be generally expressed in the attribute version. For an ordinary attribute, this multiplicity is 9, and for an identity attribute is 0.1. Now look at the figure. It shows that the equivalence of association and attributes, multiplicities, visibilities, and the ordered and unique constraints, and the indication that the feature is derived can all be mapped from the association notation into identical attribute notation. So association, as I described earlier, they are linked to each other. So if you're going to look at the example from the top, A and B are linked with each other, but we replace them to attributes. Instead of linking them, why not set the attribute to A? So BRM, that's for B, but we instead put that detail inside A. Ganun. Next, introduce a primary key. This transformation applies to any persistent class. If the class does not already have a primary key, it introduces a new identity attribute of integer type. For this class, together with extensions of the constructor of the class, and a new get method to allow initializations and read access of this attribute. This is an essential step for the implementation of data model in relational database. So introduce primary key. So as you can see here in this table, we don't have yet the primary key, but we have we have added a primary key here. Ito, a key, integer identity, and T1 and T2. These are all from here. This is our primary key. Okay, get a key from integer. So we just added or introduced a primary key to the existing table. Next is replace associations by foreign keys. So this transformation applies to any explicit many-to-one association between persistent classes. It assumes that primary keys already exist for the classes linked by the association. It replaces the association by embedding values of the key of the entity at the one end of the association into the entity at the many end. So in simple words, one to many. This is an essential step for implementation of a data model, a relational database. So this one is replace association by foreign keys. So it's actually so as you can see here, they are linked again because of this line, but we separated them. And however, we introduce a new key here, because here, if you're gonna look, B key S identity, but it doesn't have a key T, which is ito under A. Kaya siya nakalink rito para ma-associate yung foreign key na ito. However, we can do like this naman. Just put the A key T or the foreign key T directly under the B instead of associating them. So that is replace associations by foreign keys. Foreign keys, di ba? I remember kay Sir Al, foreign keys is you are calling a primary key from another table. I'm not sure if I'm correct, but yeah, that's how I understand it. And ama amalgamate subclasses into superclass. So this transformation is the opposite of good object-oriented design. It amalgamates all subclass features into one class and includes a flag to indicate which class the current object really belongs to. So this is one strategy, a strategy for representing a class hierarchy in relational database. So hierarchy, look, they are connected. So hierarchy, we know that naman, di ba? Hierarchy. Next, make association into index. So this replaces an association I in that I that identifies a member of another role set to the same class by an integer index. So this will result to data structures more being simple, more simpler and more efficient to implement. Because here, the first picture on the left, I can say that this one is kind of complicated, but on the right side, it's simple. So make association into index from complex diagram to simple diagram. Target splitting. This transformation refines the behavior of a state chart by introducing substates of a state and splitting a transition to S into cases for some or all of the substates. A simple behavior may need to be refined into subcases. So target splitting from the word itself, split. So we have here on top A and B, A, but B, we split it into two. We have B1 and B2. Next is source splitting. So this transformation refines the behavior of a state chart by introducing substates of a state and splitting a transition from S into cases for each of the substates. A simple behavior may need to be refined into subcases. So a simple case with two states is shown in the figure. So earlier on the target splitting, any split natin is the target. So if you're gonna look at the arrow is pointing to B because that's the target. However, this one source splitting, we are going to split the source, not the target. So this is the source. This is where all the data is coming from. So table A, we split it into two. We have A1 and A2. Yeah. Next is express a state chart in pre or post constraints. So the encoding of the state chart as explicit data and updates to this can facilitate the generation of executable code to ensure that objects of the class obey the dynamic behavior it describes. So the encoding of the state chart, it's explicit as mentioned here. This transformation will turn the state chart of a class C into a new enumerated type. Sorry, I don't have the figure for this one. Next is flattening a state chart. This transformation removes a composite states and expresses their semantics in terms of their substates instead. A transition from a composite state boundary becomes duplicated as a transition from each of the enclosed states if they do not already have a transition for that event. A transition to the composite state boundary becomes a transition to its default initial state. So for this one, I will admit that me myself, I had a hard time understanding this diagram, but this transformation flattening a state chart, it will reduce the complexity of the construct used to express dynamic behavior, making this behavior easier to verify, although the size of the model will be increased. So yeah, as you can see, nag-increase nga yung size ng model or yan ng diagram natin here. The figure shows a typical case of elimination of a composite state. It shows the elimination of a concurrent composite state. Note that the transition for the same event into components of the same concurrent component state must be synchronized. So why? Because this is the semantic variation point in the UML. Semantics in which transitions for the same event can also occur independently are also possible. Lastly, design patterns, the last category. Many design patterns can be viewed as model transformations, either as refinements or as a model enhancements. For example, the builder pattern can be introduced as a segregation of construction code from other parts of a class according to the disaggregation transformation. So disaggregation, kanina we tackled that naman na. The template method pattern can be introduced by the factor operations and introduce superclass patterns as described previously. So example for this one is, I know I have one subtopic lang for this. Introduce a state pattern. An operation may consist of many cases, one for each element of an enumerated type. This explicit conditional choice can be made implicit by using polymorphism and separating the behavior for each case into a separate subclass. Now, if we're gonna take a look at the figure on the right side, it shows a general situation wherein membership of subclasses for state, example A1 for state 1, A1. In the refined model should coincide with the state attribute having the same state as its values in the original model. Okay. Introducing state patterns. So state A1, state A2, we have two state here, but they are all the same under table A. Yun. It's like breaking down lang din. No? Pred 1, pred 2, pred 2. So we are like breaking down the details of this table into two. Yeah, two. Introducing state pattern. States. Okay. And yeah, thank you so much. That is all for my report today. So based on my understanding sa book, no, my chapter is the last chapter. It's like the summarization of all the model transformation that was covered from chapter 1 to 10, I guess. But thank you. I hope you don't have questions. Thank you.
Okay, thank you very much, Madam. Okay, so again, thank you very much, Madam. Okay, the model transformations are a central element of a model-driven development, no, yung na-discuss natin na MMDA approaches, such as the model-driven architecture, no, na covered na rin natin. Tama naman si Madam, no, a summary of all the entire book, no. So the correctness, the modularity, the flexibility of model transformation is critical, no, to their effective use in practical software development. So our presenter, no, described techniques for model transformation specification and the implementation. She actually focused particularly in the UML SDS approach for the automated derivation of transformation implementation from higher level specification, which uses specification and implementation patterns to guide the choice of implementation strategy for a particular problem. No, she illustrates also the approach using several model transformation case studies of different kinds, yung re-expression, refinement, quality improvement, and abstraction transformation. So we need also to understand that the model transformation is the key ingredient for bridging models with the final code that will ultimately be executed. No, its main advantage reside in the fact that it is automatically processed, tedious and error-prone manipulations on models or code, and it can be easily actually repeated if modifications of models are necessary. It is especially important when different models need to be integrated, no? But also for ensuring consistency between models and correct refinement of codes. And this entry relates to the way transformations are used in the engineering process. No, we have model-to-model transformation, normally serve the purpose, no, but are not restricted to or refining models between abstraction levels and model-to-text transformation are traditionally used for generating textual artifacts from models, no, and particular code test case driven, no. So again, the future challenges of the model-based testing achievement, of course, is model transformation can have an impact on all phases of test generation. Okay, so there are two approaches that are focused on improving the test generation process and the test quality respectively, no? So again, there are some discussions showed to use model transformation to improve the test generation process for evolutionary test generation. So in test generation that is based on evolution, a fitness function is used to select the set of the p-test test cases. So the fitness of this test, no, cases is measured, no, by the distance and even by the actual variable values to a desired value. So a while ago, our presenter described a rapid prototype of the MPM ontology and so on. Okay, so regarding the notion of transformation, it is stated that the concept of transformation is fundamental to ME, but there is currently no consensus on the corresponding terminology on the broad and must be specified. No? So we have model transformation, creating abstraction, we have creating model, and we have of course code generation, no, na hindi pwedeng mawala lagi. So most commonly, excuse me, of course, the structured analysis and design of or analysis of objects, no, in their communication is based on the TFI, no, TFM, no, the topological UML model, no, and we consider the functional features, cause and effect relationships, logical relationships, and so on. Okay, so I think that's it for the discussion, no. Thank you to our presenters, no, for today.